Hello, welcome to Statistics here at Kenyatta College. My name is Ray Lapuz. In this video, we're going to be taking a look at several hypothesis test problems, and we're not going to solve them, but we're just going to identify a few important features so that we would know how to approach the solving process. So we have to determine what algorithm to use, which type of test it is, which parameter you're testing, etc. So here are a couple of things we're going to look for. We're going to ask if this is a 1 or 2 sample test. And then we're going to test, we're going to ask ourselves, are we testing the mean or the proportion? And if we're testing the mean, we have to ask ourselves, is sigma known or unknown? And if it's a 2 test mean, we have to determine if this is independent or dependent. So here are the handful of questions we're going to ask ourselves, and from there we should be able to tell what kind of test we're going to do and which distribution to use. Let's get started with the first one. A particular brand of tires claims that its deluxe tire averages at least 50,000 miles before it needs to be replaced. From past studies, the standard deviation is known to be 8,000. So the standard deviation known to be 8,000 looks like that is a given sigma. So sigma is equal to 8,000. As we're reading that, we're just going to take this note. A survey of owners found that 28 tires surveyed, so that's going to be your N. The mean lifespan for those surveyed was 46.5, so that's X bar. And then this standard deviation is S. S is equal to 9,800. And so just so we're clear, our X bar is equal to 46.5, and our N is equal to 28. All right, so our questions, is this 1 or 2 sample? I think this is only coming from one tire place, so this is 1 sample. And we're testing the mean, we're looking at averages, etc. And if we're testing the mean, is sigma known? Yes, it is. Sigma is known. And so because sigma is known, we're going to use a Z test. We're going to use a Z distribution. And this is a 1 sample problem. So it's a 1 sample Z test, and you put in the information. First you set up the hypotheses, you put in the information, draw your conclusions, and then write your results. All right, on to the next one. Next one says we have 42.3% of Californians and 19.6% of all Americans over the age of 5 speak languages other than English. Using your class as a sample, conduct a hypothesis test to determine the percentage of students at your school who speak languages other than English at home is different from 42. So this, well, first of all, it looks like there's a couple of proportions that we have, but they're only asking us to do 1 sample testing, and then that's to use your class. So this is a 1 sample test. And then I did say it's proportion. I don't see the word mean or average anywhere. More importantly, I see some percentages there. And if we know it's a 1 sample, it's a proportion, I think we've figured it out. This is going to be a Z test. So this is a 1 sample proportion test. And Z distribution is what they're going to be using. Okay. All right, on to the next one. Cost of daily newspapers varies from city to city. However, the variation among prices remain steady with a standard deviation. Oh, they give us a standard deviation again. A study was done to claim the mean cost of newspaper is $1. 12 costs yield a mean cost of 95 cents, and the standard deviation is this. Do the data support the claim. So the claim was something about this a dollar, but it looks like here we have sigma 20 cents. We have out of the 12, n is equal to 12, the mean cost for that, so that's x bar, because that's related to the 12 newspapers, and this is S, the standard deviation, and again related to the 12 newspapers. Whenever we have the population standard deviation, we generally don't bother with this because we're just going to use the z-test. So in this case, we have one sample, and then sigma given. So this is going to be a z-test. Okay. All right, moving along. Article in San Jose Mercury News stated the students in the California State University systems take about 4 years on average to finish their undergraduate degree. Suppose you believe that the mean takes longer. You conduct a study of 49 students, obtain a sample mean of 5.1, and then standard deviation. So I don't see anything about the population standard deviation. So sigma is not given. By the way, this is one sample test for a mean, and sigma is not given. We don't have to worry about whether the samples are independent or not because there's only one sample, and I think that would be it. When your sigma is not given, let's write down the other stuff here. N is equal to 49. Our sample mean is 5.1. That's x bar. And our sample standard deviation, S, is equal to 1.2. Remember, we use S and not sigma. All right, and since sigma is not known, we're going to use a t-distribution. So this is a one sample t-test, or just a t-test. Okay. All right, and if we care to know, or somebody needs to find out, our degrees of freedom, because we're using a t-test, will depend on your n. So n minus 1 is 48, and that would be your degrees of freedom. All right, a couple more here. We have the mean number of sick days for an employee is believed to be about 10. Members of personnel department don't believe this figure. They randomly survey 8 employees, so let's write down n is equal to 8. The number of 6 days took for each employee is going to be given as follows. So we have the data here, and so from here somehow we're going to need to figure out our x bar and our s, but nowhere in this scenario are they giving us sigma, so sigma looks like it's not given. All right, and I'm only seeing one sample, and clearly we're looking for the average, mu, and I think that's it. So now we can know what kind of test this is. This is going to be a one sample. Sigma is not given, and so we're going to use a t-test. And again, if we're using a t-test, we better be ready to figure out what df is, and it's going to be n minus 1. So they gave us n is equal to 8, so n minus 1 is going to be 7. All right, let's see, one more. Life magazine reports 25-year-old mothers of 3 worked. 25-year-old mothers of 3 worked on an average of 80-hour weeks. Recently, many groups have been studying whether or not women's movement has in fact resulted in an increase in average work. So they're looking for the increase in work. Combining employment, work at home. Suppose a study was done to determine if the mean work has increased. 81 women were surveyed, so this looks like it's going to be your n. The sample of that is going to be X bar, it's 83, and the sample standard deviation was 10, that's S. Oops, that is S. And then does it appear that it has increased? So you'll figure out what the mu that you're testing for your null and alternative hypotheses are. So this is what we have. It does not look like sigma is given, is not given, but we're still doing one sample. And since sigma is not given, we're going to use a t-test. So the t-distribution. And again, when you're doing a t-distribution, be ready to figure out what your degrees of freedom is, and your degrees of freedom is 81. All right. These are all examples of one sample. So we're going to go to the next page and take a look at some more sample hypothesis tests. Okay, in this problem, we're going to take a look at some two-sample test. I didn't separate or mix it all up. But we'll see why it's two-sample as we read through it. The first one, the mean number of English courses taken in a 2-year time period by men and women college students is believed to be about the same. An experiment is an experiment is conducted and data are collected from 29 men and 16 women. The men took an average of 3 English courses with a standard deviation of 8. The women took an average of 4 English courses with standard deviation of 1. Are the means statistically the same? So clearly these are two samples because we're looking at the men and women. And for the men and women, we should be able to identify the basic statistics. So 29 men, that's going to be your N for the men. And just because I wrote this down first, we're going to put N sub 1 there. That's 29. And N sub 1 is going to be 16. Now the X bar, the mean, they say they took 3 English courses, whereas the women took 4 English courses. So I want to put the subscripts here as well to match with the men and the women. So I'm just going to say this is 1, this is 2. And then the S, this is the sample standard deviation. For the men is 0.8, and for the women, oops, this is S1, and S2 is going to be 1.0. Okay, so we're testing the means, the mean mu for this. So you're going to have a mu1 is equal to or not equal to or whatever to mu2 in comparison. So I'll let you figure that out, but the bottom line here is that this is a two-sample. Our sigma is not given. Sigma not given. And because our sigma is not given, we're going to use a t-test. All right. The other thing is that because we're testing the means and we have 2 samples, we have to check if they're independent or not. And it looks like there's 29 men and 16 women, so we should have also noted that this is not independent. Which means we are going to stick with this 2-sample t-test business to go. Now this is going to have a degrees of freedom, but we're not going to worry about that because the calculation is kind of complicated, and we'll just let our computers and calculators deal with that. All right, let's go to the next problem. The next problem, some manufacturers claim that non-hybrid sedan cars have lower mean miles per gallon, MPGs, than hybrid ones. Suppose consumer tests 21 hybrid sedans and got a mean of 31 and a standard deviation of 7. 31 non-hybrids get a mean of 22 and standard deviation of 4. Suppose the population standard deviations, okay, here they give a population standard deviations are known to be 6 and 3 respectively. Conduct the hypothesis test. So clearly this is a 2-sample test. Sigma given. So this is going to be a Z 2 sample z-test. All right. We don't have to for these problems, but if you're doing this for reals, you should write these things down. But let's say hybrid and non-hybrid cars will be our 2 categories, and we'll call this group 1 and group 2. So N for group 1, how many hybrid cars did we look at? 21 hybrid cars to look at, and the mean for that is 31, and the standard deviation for that is 7. Now these are all hybrids, so I'm going to call them sub 1. For the non-hybrids, there are 31 that was tested, so N2 is equal to 31, and then they give us the X bar for that group. Had a mean of 22 mpgs and a standard deviation of 4 mpgs. Now they also gave us more information here about the population standard deviation, and since we have been dealing with the hybrids first, we're going to assume that the first number 6 here is given as a standard deviation for the hybrid cars. That is 6, and then the second standard deviation is 3, and that's given for non-hybrid cars. So when you do your tests, you're not going to use the sample standard deviation because they give you this. And then but clearly if the N1 and N2 are different, then this is clearly not independent. But that's not the only reason why it's not independent. You can tell if something's dependent if they are intimately related. In this case, they're not. So 2 samples are independent. So because of that, you will be using a 2 sample z-test. So 2 samples z-test, and yeah, you should be able to carry this out. Of course, you'll figure out what the claim is and all that other stuff. All right, let's take a look at the next one. A recent drug survey showed an increase in drugs and alcohol use among high school seniors compared to national percentage. Suppose the survey of 100 local seniors and 100 national seniors are conducted. See if the drug proportion and alcohol use locally, nationally. Locally, 65 seniors reported drug use within the past month, and 60 national reported not using them. So I think this is going to be a proportion problem because, first of all, they're not showing any averages or means, and then here they're saying 65 out of 100 local seniors are kind of getting grouped together. So clearly we have 2 samples, and this is a proportion test. And so automatically this will be a z-distribution test. And now that we know that, well, it's 2, I think it's in the calculator, it's called 2 prop z-test. The proportions are always z-tests. But that just means we're using the z-distribution. And so you can separate this by locally and nationally. And all you need is X and N for each one, and we'll call the local sub 1s and the national sub 2s. And then locally there's 65 out of 100. And then nationally there's 60 out of 100. And they're not asking for this, but this will help you find P prime, which is 65 over 100. That's 0.65. And P prime, well, I guess we should label this P prime 1. P p prime 2, and that's 60 over 100. And then you can work with that. I think in most calculators and computers and the program that we got set up, all you need to do is you plug in your x and your n, and then you get your value. All right, so that is that. Let's do another one here. Marketing companies have collected data implying teenage girls use more social media than boys do. In one particular random study, 40 chosen teenage girls and boys, 20 of each with smartphones, and the mean number of social. Okay, let's read that again. In one particular study of 40 randomly chosen teenage girls and boys, 20 of each. Okay, so there's girls and boys, 20 of each, with smartphones, and the mean number of social media apps, the girls was 3.2, standard deviation was 1.1. For the boys, mean was 1.7, and standard deviation was 0.8. Conduct a hypothesis test for the means approximating if there's more girls is higher than the boys mean. Okay, two samples, two samples, and then we have the girls and boys. Girls were mentioned first, and so I usually put whatever's first to be the first group, and the boys were mentioned second. And I do not see no sigma given. So there's no sigma given. We're going to use a t-test. All right, and the data for the girls and boys, this was a little confusing, but after reading it a couple times, we got n1 is equal to 20 and n2 is equal to 20. Now, for the girls, the mean was 32, so that's x bar 1 is 30 or 3.2. Standard deviation is 1.5. That's S1 is equal to 1.5. For the boys, the mean was 1.7, so that's x2 bar 1.7, and then the standard deviation was 0.8. Again, no sigma given, so we're going to use a t-test. So this is going to be a two-sample t-test. Now, when we had one sample t-test, we usually say, hey, let's figure out the degrees of freedom, because it was easy enough. The degrees of freedom for this t-test is a little bit more complicated, so we're not going to go through that because our calculators and computers can figure it out for us. Okay, that's it. And let's do one more. All right. A golf instructor is determining if her new technique for improving players' golf scores is effective. She takes 4 students and records their 18-hole scores before learning the new technique and after. So here we have 2 samples, and the 2 samples are what happened before and what happened after. And so clearly, well, not clearly, but we are testing for the means. And with 2 samples, we're noting that this is actually dependent. And so I think it'll be clear when you're testing for the mean and it's dependent, because you'll usually get a table of values about before or after, about something versus something. And the key is that they are all related to each double score, or each score from each of the 2 different samples come from one source, in this case the golf player. Okay, so because of that, we're going to summarize this into just a single t-test. Single t-test. So although it seems like we are, not that it seems like we are in fact testing 2 different samples, but we're going to look at the difference between them. So this first number here is going to be the difference. It's usually before minus after the difference when, or the first the first sample minus the second sample. And so we're going to construct a new set of data that comes from here. So 83 minus 80 is positive 3. This went down, so that's a negative 2. This went down, so I think that's a negative 7. And then 87 minus 86 is positive 1. Oops. Let's do that again. I think this went up. So 93 minus 86 is positive 7. All right, let's double check that. Yeah, so we got one negative number, the rest are positive. All right, so what you'll do here, these are all your x sub d's, they call them. This is your x sub d's. And what you need to do is you need to produce your x bar sub d and your s sub d, and then your n sub d, or just n because it's all the same for this thing, is equal to 4. So these things you'll have to find them by doing the statistics. And if we use the formula, or if you use the program that we created for this class in Google Sheets, then you just type in these values. You type in these values, and then the program will figure these values out, and then in turn figure out these statistics that we'll need. And if you do that in the calculator, you can also type this into L1 and L2, and then you produce L3. You get this, and then you do your one variable t-test. So this is just a regular t-test on x sub d. So this is your variables. So this is technically a 2-sample dependent set, but when it comes down to the testing portion of it, you're really using a single t-test, because you're going to subtract each number or each pair of number, and then you're going to use the new result and then run a t-test on that. All right, that is a lot, but if you stuck through it, you can see the thought process of determining what kind of hypothesis test you're dealing with, and that would be extremely important for you to be able to get through this class. Okay, that's it. Good luck. I hope that helps. Good luck. Bye.